lever rule. What is the lever rule? Okay, so for defining the the phase system, that we need to know the lever rule. What is the lever rule? Lever rules is basically the number and composition of the phases can be found from the phase diagrams. So the number and composition of the phases, how many compositions are there and how many phases are there, so that is being defined with the help of lever rules. Okay, so in suppose in take the example of the two phase system. Okay, two phase region, basically this particular region is two phase region, right? Because above you are only liquid and below you are having solid only. So that line which define this category is known as the liquidus line and the solidus line. So this particular line, this particular line with the green is known as your liquidus line. This is your liquidus line, and orange one you are having your solidus line. Okay, and in between these you are having your two phase system. Okay, means the you can say is a semi solid or two phase occur together, means liquid and solid both exist together. Okay. So how they define, just for determining the the phase, what we can determine the relative amount of each phases that present from phase diagram using the relationship called the lever rule. So how you can apply the lever rule? It's very obvious, very simple. Okay, you can see at what temperature that you are supposed to calculate. So just define the temperature. Once you have defined, just draw the horizontal line. Okay, and see at what point they cut. You know, they cut the solidus line and liquidus line. So as you can see in this point, the O point or 0 point O is the intersection point of that particular line that we have drawn at the liquidus line. And we talk about what the point or the intersection point of the line that we have drawn to the liquid solidus line. So you have defined as a P as a intersection of the line that we have drawn horizontally from temperature axis, and O is the intersection point of the line we have drawn with your liquidus line. So the same line at what the point where it cuts or intersect to the solidus line and liquidus line, we have define a point. Okay, in case of here we have the 0, or you can say the O, and here the P, and in between what the kind of the phase that your mass fraction that you are required. Okay, if you have composition, if you want suppose if you need to know what is the composition here, then it would be like your the middle point. Okay, now you can apply the Deva rule. Okay, so simply whatever the because it's a composition, your concentration of by weight of your component is on x-axis, on means this axis. Okay, so you have drawn the temperature, and according to the temperature you have drawn this. At what temperature, I mean, you obviously I have already made whatever the things that you require, you need to define first one thing. If you have defined the temperature, now you need to understand what is your phase composition. If you have a composition, just draw the composition, and now you draw the temperature, and then you will be able to define how. Just simply uh, 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 you have this line and this line. Okay, so whatever the middle point that cuts, which is known as your M. As you can see here, this is the line from here to here. This particular line in particular diagram, you can see it is O to P. I mean, this the cut and this cut. Okay, so this in between these, the line that has been here, that has been written in this form. Okay, and the middle point, what is the middle point? Which cuts and on the concentration axis. So the concentration axis line which defines your concentration. So what is the intersection of this line is has been regarded as a fulcrum. Okay, once you have defined the fulcrum, now you can easily calculate the value. Simply, what is the simple rule of one? This is your weight of one I mean the weight 1 of what? Whatever the thing is liquid, and weight of 2. Okay, or you can say whatever the composition A of B. Okay, okay. So once we have defined, now the multiplication. What multiplication? W2 into PM. I mean, it's a very basic math. Okay, if you have something, then it multiplication of these two, multiplication of these two must be same. Okay, if they have balanced, if it is a fulcrum and if they have balanced, they are in equilibrium, then this force, okay, multiplication of this perpendicular distance must be equal to the force or the load multiplication of this particular distance if they are having your the system is in equilibrium, otherwise you cannot reach these conditions. Okay, suppose, I mean, you can think if this load is high, what does it mean? They will come down. Okay, if they are in this condition, it means they are balanced. Balance means they are in equilibrium. That's why it is being in these conditions. Okay, if you are, so it means both the multiplication would be must be balanced. Once you are balanced, then you would have like this: the percentage of the solid, okay, which would be OM by OP into 100%. OM means this one, OM, right? And if we talk about the OP means till here to here. Okay, so OM by OP into 100, and if we talk about the percentage of liquid state, then MP by OP. Okay, so this one is for the liquid. Okay, just opposite of sense. This is the liquidus lines. Okay, and this is solidus line. So if you are need to required, if you are basically need to calculate the solid, then you need to calculate this one area, this one line, multiply. And if you are need to calculate the liquid, then you need to this one. Okay, so that we have defined here. So for solid, the solid, you have solidus line at bottom, right? This is solidus line, and if you need to define the solid percentage, then you need to calculate the opposite of this. Okay, OP, and defined by divide by whole in the both the cases. So OP by OM by OP for solid. And if we talk about for the liquid, the liquid line is this one. Okay, then you will have to take this opposite sense, opposite of the line. So for the liquid, you need to know MP divided by whole over OP, which is common for the both. Okay, and percentage of multiplication of 100 means to define the percentage. Okay, that is. So you can easily calculate the value of the concentration of both of solids, both of components, right? And obviously OM plus OP, OM plus MP would be OP, right? Obvious, it's a very simple thing. Division this plus this would be same, right?